So section 2.1, solving inequalities in one variable. First, let's take a look at our objectives. We're going to solve the simple inequalities, but then we're also going to graph them on a number line. Alright, so first let's look at properties of order. Start with comparison property, which states exactly one of the following three are true. A is less than B, A is equal to B, or A is greater than B. And when you think of any two numbers, either they're equal to each other or one is bigger than the other. Next is the transitive property, and this is similar to the transitive property of equality, which is like the chain rule we talked about. Here it states if A is less than B and B is less than C, then A must be less than C. And if you think about any numbers in this set, you could say if you have $2 and your friend has $5, but then your mom has $10 and you have less than your friend, but your friend has less than your mom, you must also have less than your mom. So you're comparing three things of order of magnitude. The addition property of inequality simply says that, like the addition property of equalities, you can add a constant to each side of the equation. So if A is less than B, then if you add C to both sides, you get A plus C, and that's still less than B plus C, because you're adding the same quantity to two different numbers that were compared originally. And finally, the multiplication property tells us that if A is less than B and C is positive, then AC is just less than BC. But here the next part is interesting. It says if A is less than B but C happens to be negative, so if we multiply both sides by a negative, we then say AC is greater than BC, which ends up meaning that we have to flip the direction of the inequality sign. Let's take a look at our first example here. We've got solve and graph. 3x plus 16 is less than 7. So let's take a look. Solve it just like an inequality. We'll subtract 16 from both sides. We're going to have 7 minus 16 on the right-hand side, giving us negative 9. Then we divide by 3 on both sides. We have x is less than negative 3. Well, what are all the numbers less than negative 3? Here you have to remember that you're not talking about just integer values. So don't start by saying negative 4, negative 5. You need to start at negative 3.0000000, infinite amount of zeros with a 1 at the end. So start at the closest thing to negative 3, but not on negative 3, because it doesn't say less than or equal to, it just says less than. So on a number line, if we wanted to graph this, we go to negative 3. We put an open circle to indicate that it's not including negative 3 in our answer. We'd shade everything to the left, which is the definition of less than. That would be our solution set on the number line. Our solution set would look like the following then. For example 2, let's take a look at this. Make it easier on yourself. See that this 3 halves is one of the fractions, or one of the coefficients, and just multiply both sides by 2. So start by multiplying by 2 on both sides. That'll get rid of the denominator. It becomes 22 minus 3r greater than negative 8. And now we can solve this like any other inequality. Subtract the 22 from both sides, you're going to get negative 3r greater than negative 30. Divide by negative 3, remember to flip the sign, you get r is less than positive 10. Now, if r is less than positive 10, on a number line it looks very similar to the last part. Just go to positive 10 now. You could put 0 as a reference point, but open circle, shade to the left. Again, don't forget to flip the number sign, or the inequality sign from here to here. Example 3. Easiest way to start this one is to look at our distributive property. So let's go ahead and distribute here. We have 12z minus 3 greater than 12z minus 10. Well, the problem is that when the 12z's are both there, they cancel. So what we end up getting is negative 3 is greater than negative 10. Well, is negative 3 greater than negative 10? Yeah, surely it always is. So if I were to go back to the previous line and look up here, and I added 12 of some quantity, so 12 times 5, or 12 times 6, or 12 times 7, to both sides, it would still be true. So what this tells me is that if I put anything in for z in this line right here, it's going to be true. So z is all real numbers. So z is in the set of real numbers. Give me any quantity. How you represent that on a number line? Start with the 0 in the middle, and shade everywhere. Put a double arrow to indicate it's a line that goes on forever, not just a ray. Alright, number 4 says 3 minus 2 times the quantity q minus 1 is less than or equal to 5. The first time we've seen a less than or equal to or greater than or equal to sign, right away remember that just means close the circle or shade in the circle as well to indicate that it's part of the solution set. So here, it would be useful just to, we can start by distributing. And what we get is negative 2q plus 5 is less than or equal to 5. So negative 2q is less than or equal to 0. Now, be careful here. Many people want to say, oh, it's undefined or there's no answer at first. But actually there is. There most definitely is. Divide by negative 2. Well, 0 over negative 2 is still 0. But you need to remember to flip the sign. And that's the key here. What does this tell us? That when q is 0 or positive, right, 0 or positive, this statement will hold true. Let's graph that on our number line now. Here's 0, here's 0, or positive. Okay? So that's our solution for this one. Example 5, when we take a look at this right away, I would personally divide by negative 1 to get rid of that. And I would just write 10 minus r greater than negative r plus 15. So I get rid of this negative by dividing this side by negative 1. Those cancel, and you flip the sign. I think this makes it easier personally. And what you'll notice next is the negative r's are on both sides. Those drop. Is 10 greater than 15? No, that's not true. It's a contradiction. Thus, there's no solution. So you have the empty set as your solution. No number line, empty set, or no solution, or null set. Any of those are fine. But because that statement is not true, there is no solution. And you can check for any value, nothing will work. In example 6, it says, why is the following statement true? If a is greater than 0 and a is less than 1, then a squared is less than a. Well, let's break this down. A greater than 0 means a is positive. So for all positive numbers, well, if it's less than 1, it means it's a fraction. So all positive fractions, that's what we're talking about here. So we take our symbols and turn them into words. So all positive fractions have the property that when squared, they're less than their original number. Let's take a look. If we look at 3/4 squared, it becomes 9 over 16. Well, as a decimal, that surely is less. This quantity is less than this quantity. Check it, go ahead. Here you're going to get 0.75. 9/16, think about this for a second. Well, if you had 8/16, that would be about a half. So this is a 16th over a half. It's clearly not anywhere near 0.75, even if you don't even know what the decimal representation is. That happens to be 0.5625. So what we can see clearly is that when you square a fraction that is positive, the number actually gets smaller. Again, this number here is smaller than this number here. For the homework, take a look at 2.1 and some mixed review.